1.
This is Module 9, Lesson 1. We are going to start talking about moles today. Moles is basically the equivalent of the word dozen. In everyday life, we use dozen to mean 12 of anything. The thing is, with chemistry, things are so tiny that a dozen molecules or a dozen atoms, it isn't a lot at all. So we need the word moles. A mole is 6.02 times 10 to the 23rd of something. It could be, pencils, atoms, cats, whatever. If you say a mole of something, you mean this large number right here. Okay, so, oops, I didn't mean to skip. So if we're talking about this number, realize that, well, apparently I'm not on pencil. Realize that you will see in some places extra digits. For example, 6.022 times 10 to the 23rd is on your reference table. And that's not wrong, it's just more specific than this number. There are actually more digits that come after this. You can see it rounded to different places. I'm going to ask that you do things this way. It's the most common number, I think, that's usually known for mole. It can be abbreviated as MOL. That's not super helpful, but nonetheless, if you see 3 MOL, that means 3 moles. And then the particles of something could be either atoms, molecules, or formula units. You use the word atom whenever you're talking about an element off the periodic table. Any of these things would be measured in atoms. Molecules is used for covalently bonded things. So if you have like nitrous oxide, like NO, nitrogen monoxide, or N2O, CO2, these would all be molecules because they're covalently bonded. And formula units are used for ionically bonded things like NaCl or CaCO3, whatever. Anything that's ionically bonded would be a formula unit of those things. So now what can we do with this? Well, we can use it as a conversion factor. So if you know that 1 mole of anything is 6.02 times 10 to the 23rd, then we could write a conversion factor like this, like 1 mole of carbon dioxide would be 6.02 times 10 to the 23rd molecules of CO2. That's a conversion factor. Remember that a conversion factor is two things that are equal to each other. Or you could put that, 6.02 times 10 to the 23rd atoms of sodium. Well, that's equal to 1 mole of sodium. So we could write conversion factors with this all day long, and we can use these to do conversions, which is exactly what we're going to do next. So if you need help with the conversions, then go back to Module 1. That's where we first did this, when we learned how to do the table problems. Like we had kind of like this up above, or some of them had multi-steps to them. So if necessary, go back to Module 1 with how to do this. I have some examples for us. If you will print out the sheet already, then you'll have these problems for you at the top of the sheet where it says follow me. Our first one says how many atoms are in 5.40 moles of copper? Well, the first thing that we need to do is write down what we know up here, 5.4 moles of copper. And if you remember from Module 1, our next step was to always take whatever's up here and put it in the bottom of the next fraction so that it would cancel out. So we need to put moles of copper down here. The next thing is, here's the question in the problem. How many atoms? Can we relate atoms and moles? Yes, we can. We just learned that we know how many atoms are in a mole. There are 6.02 times 10 to the 23rd atoms, and in this case it's copper, atoms of copper in 1 mole of copper. So what you're going to have to do is memorize this relationship right here, and then you're going to put this in your calculator, and putting the scientific notation in your calculator correctly is critical to getting this right. If you don't put it in correctly, then you're going to get numbers that are like they've messed up the order of operations, and you'll get really, really odd numbers. The answer to this should be 3.2508 times 10 to the 24th. Now, can I keep all of this? The answer to that is no, I cannot. We're going to have to round it based on sig figs. And this is the first time that we've used sig figs since Module 1. We're going to use them pretty frequently from here on out. So you also could go back to Module 1 to review that. This right here doesn't count with the sig figs because they're reference numbers. It has an infinite number of sig figs. So I'm only looking at this one right here. 5.4 has 2 significant figures, so my answer can have 2 significant figures. That means I get to keep the 3 and the 2. What's next to the 2 is a 5, so it's going to round it up. 3.3 times 10 to the 24th. Now these canceled, so I'm left with atoms of copper, and I'll put that on my answer. So my answer to this problem is 3.3 times 10 to the 24th atoms of copper. Okay, another example. How many moles are in this many formula units of NaCl? Well, our first step is write down the part that you know. So 6.54 times 10 to the 18th. Now, I abbreviate formula units as funds because I don't want to write all of that out. You can abbreviate it too, just make it nice. Funds of NaCl would have to go on the bottom because I know that it has to go there to cancel out. So can I relate formula units to moles? Here's the question. How many moles? Can I relate these two things together? Yes, I can. We just learned that I know how many particles, how many formula units, atoms, or molecules are in a mole. I know that there's 6.02 times 10 to the 23rd formula units in 1 mole of NaCl. Okay, funds and NaCl cancel on the top and the bottom. So this leaves me doing some math, and this is going to be one because of how the math is, where if you do not do the scientific notation correctly in your calculator, you are going to get the wrong answer. If you need help with how to put this in your calculator, under the Resource Center part of our homepage, if you go underneath the resources part of it, there's a video on there about how to put scientific notation into a graphing or a scientific calculator. So I would encourage you to use that. If you do it correctly, your calculator is going to say a bunch. It's going to say 1.0863 ... times 10 to the negative 5th. It won't say the ... By ... I mean, my calculator shows a lot more digits than that, and I don't want to write them all down. Can I keep all of this? Well, of course not. I have to round it based on sig figs. This right here has 3 sig figs. Remember, with scientific notation, we don't look at this part over here. We just look at the digits before the power of 10. There are 3 significant figures in 6.54, so I can keep the first 3 digits here. The 6 is going to round the 8 up. So 1.09 times 10 to the negative 5th moles of NaCl. So just write these down. Moles of NaCl. There's my answer to that problem. Next, how many atoms are in this many molecules of NO? Well, we know the drill. 4.5, I abbreviate molecules as molic rather than just write the whole word. You cannot abbreviate it as MOLE or MOL because, of course, those are moles. So 4.5 molecules of NO. We know this should be our next step. And we know that molics would go down here so that they could cancel out. Now, do I go to mole with this? Well, we've already said that we know how many atoms are in a mole, how many molecules are in a mole, or how many formula units are in a mole. This doesn't ask me for how many moles. This says how many atoms. Well, you should know from all of the chemistry that we've done previously that NO is a molecule. And it's made up of atoms. And if you look at the formula, it'll tell you that it's 1 atom of N and 1 atom of O. There are 2 atoms in every molecule. So this is one where I do not need that extra step. There are 2 atoms for every 1 molecule of NO. I won't be going to moles with this particular one. Why did I do this to you? Because I do have some problems where I ask you how many atoms are in something, or something along those lines. And so I do want you to realize that you already know this without doing the mole stuff. If you do the math with this, 4.5 times 2 is 9, but I need 2 sig figs. So 9.0 atoms is my answer. There's not atoms of something because it's two different atoms. It's just period, atoms. Okay, so what now? It's practice time. And I've already got the important part right here if you want credit. I need you to show me your work. I already have the answers for you on your practice problems. So I don't need you to show, well, I mean, I do want you to show the answers. I do want you to get them. But the purpose of this is to show me your work. I need to see if you know how to set these up and get the answers. I will also at some point give you some problems where there aren't any answers so that you can have a better test of whether or not you know how to do this. A lot of students get really comfortable with the answers being on their papers, and therefore they automatically know when they don't get the problem, and they'll redo things and get it done correctly because they automatically see, oh, I'm not right. Well, on a test, you don't have the answers. I need you to be confident in your ability to set these up from the get-go. Why do I need you to show me your work? Well, because since I've already given you the answers, that's kind of the only other thing that you can show me for credit. And if you need help, then when you do your setup, you can do it this way, or you could do it, with the multiplication symbol. I can see automatically, like if you put moles here, if you put moles here and moles here and don't make them cancel, I automatically know, like, you didn't set it up correctly. Like, you didn't put this one on the bottom where it should have gone. Your setup's wrong. Or if your whole setup is correct, then I can look at it and see, like, well, you set it up properly. If you still didn't get it, then it must be what you're doing in the calculator. So it will help me help you if you end up needing it. So go do the rest of the practice problems and be sure to ask me if you need any help. Best of luck.